Hello, gents. Hope you are all well. Hope you are not getting too bored. And I'm sure you've been very much looking forward to this, which is the highlight of your week, which is your physics work. I promise this will only take 40 minutes, there or thereabouts, give or take, sort of 5-10 minutes either side. So, not to worry about the mass hysteria that we had last week. This is definitely a nice compact exercise for you guys. So this week we're going to be looking at P3.2. So we are continuing from the stuff that we looked at last week. And just before I move on, do refer to the Caboodle books when you come to do the tasks. Obviously, all the notes are in there, and it will just give you some guidance should you need that. The page numbers are there. If you're using the triple book, it's slightly different to if you're using the combined book. Okay, so as you should have done last week, you should have obviously have made a physics book in GoodNotes as part of the school closure program, just to make sure that things are nice and tidy, and that you know where all your work is and that you're able to submit it or take it and submit it into the right folders. So just bear that in mind, please. Right, okay, so by the end of this week, assuming that you do this throughout the week, or you can do it in one setting, but by the end of this particular task, we hope that you will become familiar and be able to talk about how wind and water are actually used to generate electricity. And then from that, I've said to be able to use this knowledge to attempt 6 marker questions. Now, the reason why I've focused particularly on 6 marker questions or longer extended answers is because this topic actually lends itself really well to those longer answers or those longer type questions in the exam. It's a fairly straightforward topic. Much of the information that we go through actually you probably already covered at Key Stage 3, I imagine, in either science or even maybe geography. And so the scope for answering questions in a little bit more depth is probably going to be the main difference at GCSE. So we're going to be looking at that, and the tasks that I've prepared for you guys is really just trying to grapple with some of these longer questions. All right. So there are 4 main ways in which we can actually harvest wind and water to generate electricity. And you need to be able to confidently talk about all 4 of them, and they are all very different. Obviously, they're connected, but you should be able to describe each and every one independently. I think there's sometimes there might be some confusion, certainly between hydroelectric and wave power, but they are quite distinct. So, wind power, wave power, hydroelectric power, and tidal power. Now, of course, I forgot to mention as I'm talking and giving this introduction, please feel free to obviously pause, making sure that you're getting your content down and your notes down as you would do in a normal classroom setting. Of course, I'm just going to be talking and asking you to pause at different sections, but please feel free to do this at your own pace. So, looking at wind power, and I think this is probably the one that everybody's most familiar with, simply because we see these wind turbines, and they come in all sorts of different versions, different shapes and sizes, but there is some commonality between them, and that is, of course, their function, which is to generate electricity. Um, and really, the principle of how they generate electricity is very much dependent on blades rotating, so the rotor mechanism with the blades rotating as a result of the wind. So there's a force being exerted on the blades, they rotate, and as you can see here from the diagram, the blades are connected to a drive shaft. The drive shaft, via several gears, is rotating, and that is actually powering the generator. Now, within the generator, there are electromagnets, and a mechanism of generation of electricity actually takes place in the generator. That's actually something that you're going to be looking at in more detail in year 11. How does a generator actually work? But for the time being, you just need to know that the blades are spinning, and this powers the generator, which then generates the current and travels down wires, cables connected to the national grid. Now, in terms of wind power, these wind turbines, you need to know about their disadvantages. Obviously, the advantages are obvious, that they can produce this generation of electricity without using any fossil fuels. And of course, there are environmental benefits to that, not emitting any CO2 and or any other toxins or any other pollutants. Wind turbines are very loud. I don't know if you've ever seen a wind turbine, but last year I went down to the Lake District, and on the outskirts of the Lake District, while there are none inside the Lake District, we can talk about why that might be actually in your 6 mile question. As you drive past them, they must have been probably about half a mile away from where we were, you can hear a very distinct and loud humming noise. So they are considered to be quite loud. And in fact, it says there in the note, this is known as noise pollution, because it does certainly pollute any, in terms of noise, pollutes your environment that you're in. And some people also don't like the way that they look. They are considered an eyesore, and especially in areas of outstanding natural beauty or tourist hotspots, this is not something that people would want there. So wind turbines, again, there are major advantages and there are major sort of, perhaps some people consider less uh, significant disadvantages. But the advantages, as I mentioned, especially in a country like ours, where some regions are extremely windy, then effectively what you're doing is you are able to harvest free and actually in certain areas quite reliable energy. However, in general, the as you can see, the first disadvantage is that it's unreliable in the sense that some days there is no wind at all, or the degree of the extent of the wind fluctuates, goes up and down, and so you can't really control how much electricity you're generating, simply because you can't predict with accuracy how much wind you're going to receive that day. I mean, obviously not including weather forecasts and stuff, but if you're talking about powering a village or something, then the forecasts and the demand of that village may obviously not tally up together, and you're left with the situation where you are not providing for the demand. So the wind turbines is actually, out of all 4 methods we're going to be looking at today, is actually the cheapest one to construct, and it's one that has it was the very first method, or the very first source of energy out of the renewable sources that people were actually able to harvest, it and solar powers. There was a very good film that I watched actually about a boy in an African country who constructed his own wind turbine. I can't remember the name of it, but I'll look it up after this video and I'll drop it into the comment section. It's definitely something that you guys can look into. It's a true story, fascinating. Anyway, so moving on from wind power, you've got hydroelectric power. Now this is very, very specific hydroelectric, because it's the utilization of dams or a construction of some sort of barrage across a water source. Now, this is with this sort of question you might get in the exam about hydroelectric power and even about tidal. You need to make sure that the work that you did in P1, which was all about energy transfers, is something that you recap, because the language of energy going from one store to another is going to be very, very important, as you're going to see in some of the questions that we're looking at. But effectively, water is held behind a dam or a barrage, storing energy in the gravitational store. The water runs through pipes, so it's controlled. The flow of water is controlled, and that flow of water, as it did with the wind turbine, is actually powering a generator. So it's causing the drive shaft of the generator to spin, and as a result, that generates a current or electricity, um, and that current is then connected to the national grid via long distance power lines and cables. This is There are quite big hydroelectric power stations. In One of the biggest actually in the world is in Egypt, across the northern part of the Nile, and these are long-term projects. There's quite a few big ones in China as well. I think the largest dam is in China, and these are reliable as far as I suppose it can be, in the sense that certain countries have certain monsoons or they have seasonal rains which allow for water supply to actually build up. And so these dams are built in strategic places where they know that they're going to get an increase of water, and then they can actually control the flow of water, having built it up over a long period of time. And then that way they can actually disseminate the power generated to the villages and the towns around the actual dam itself in a controlled rate. The advantages of hydroelectric, as I mentioned, it is reliable, as you can control the rate of water, and therefore control the rate of generation of electricity. It says water can be saved for use when electricity demand is high. So again, seasonally, people, especially in hotter climates, might, for example, use up more electricity during the day, where air conditioning, which, believe it or not, in countries around the world, in really hot countries, is more of a necessity than it is a luxury here in the UK, where we tend to have much more mild weather. And so, our seasonal changes in terms of use at home might be very different. Dams are designed to last many decades. These are robust concrete, with fortified steel structures. They are designed to last for generations. The lake can serve as a tourist attraction. The Hoover Dam in the US is a very, very good example of that. And there's a few around the world that also do that. It also attracts a lot of wildlife. One of the points that I haven't put there is it creates new habitats for animals and other species in that particular region. And some dams have even been populated with certain species of fish, and people can even go fishing there. Disadvantages: these are major construction projects that can cost millions or even billions in terms of costs. They must operate for decades before they actually pay themselves back. So, as I said, it is a long term. But to be honest, if you're building a dam, is going to be long term anyway. Flooding of large areas required. This was quite a big problem when the Aswan Dam in Egypt was being built. So, whilst it was promising to provide Cairo with cheaper electricity, it was to the detriment of villages and smaller towns further down the Nile that would have effectively had to be evacuated or vacated. The land needed to be emptied from all people, because it was going to act as the floodplain for this new man-made reservoir and dam. And that's obviously the point that it mentions there, that people sometimes must leave their homes for land to be flooded. And again, natural habitats are destroyed. So whilst new ones are created by the reservoir, no doubt that the land that was there before the reservoir would have also have been a habitat for different animals and species. So there's clear advantages and there are clear disadvantages of hydroelectric. Tidal and wave power, I've grouped these two together because I suppose whilst they are related, they are somewhat mutually exclusive, but there is a very obvious obvious common link there. Both rely on the flow of water, but the difference with tidal and wave power is that there's a bit more control in terms of the rate with hydroelectric, whereas with tidal and wave, the natural limitations, I think, come to play a bit more. Obviously, with tidal power, this is only happening twice a day, and you really need to pick your location. So not all locations are equal, although all the world's coasts actually experience a tidal flow. However, not all would actually be suitable for tidal power. So it says water from the high tide is trapped behind a barrage and is then released through the turbines, turning them, which turns a generator to generate electricity. For us here in the UK, the Severn Estuary is a very good example of that, where the opening actually on the sea narrows as it goes inland. So actually, the geography of the region provides a natural funnel for the water to come in when the tide is in. And so they have a chain of turbines and generators across the pretty much an entire section of the Severn, and it provides some very reliable tidal power. So the tides, although they are perhaps higher and more powerful in certain parts of the year, this is known and it can be anticipated for. So from that, in that regard, it is quite a reliable form of energy source. Then you have wave power, and here wave generators actually sit on the surface of the water using buoyancy aids, and they basically rock forwards and backwards with the motion of the waves. And again, this rocking motion turns a generator, and the current that's then generated is actually sent down cables. So all of these, the wave generators and the tidal power generators, they all have to be physically linked with each other in terms of cables, and the cables then stretch all the way back to mainland, where it's then connected to the national grid. So obviously with tidal power and with wave power, this is offshore, whereas with hydroelectric and wind, this is inshore. Of course, wind power can also be offshore. So again, the advantages of tidal and wave power, the advantages, as with all the ones that we really spoke about, no pollution in terms of chemical. With wave and tidal power, there isn't really noise pollution either. So in that regard, it has an advantage over the other two. It's a free energy resource. You can predict the tides, therefore you can predict the energy output. It's an infinite resource. Low maintenance cost. Disadvantages, as with most renewable sources of energy, the cost of setup is very high. So very similar to the building of the dams. Generation is for a short period at tide peak. So again, whilst it's very good to be able to predict when the tides are coming in, they are only lasting for a very short period of time. Few ideal locations along coastlines, as I said. The geography needs to be just right, and they can obviously, disrupt the habitats and the local wildlife that live in very close to the coast, or perhaps the regions where these generators are actually being built. So I've added this slide here, actually, so sort of summary of all renewables. Now, whilst we're only talking about wind and water sources of energy, all of these can actually be all of these can actually be used for the other renewable sources of energy, which we're going to be looking at next week and the week after. But the main advantages of renewable sources of energy are zero fuel costs, They are sustainable. There's no pollution in terms of CO2 being released into the atmosphere or any oxides or dioxides. Hydro can meet sudden demand, again, because you're storing that water. So, whilst we have an issue with energy storage, we can, of course, store water and then rely on these energy transfers between gravitational potential energy stores into kinetic energy stores to actually meet sudden demand. And although we're not covering solar in this particular lesson, it says here that solar good for remote locations. I watched, I think it was an ASAP Science video that said that a solar field the size of Greater London actually has the ability to power the entire globe for a week. Now, Greater London is pretty big, and the biggest solar farms, I think the biggest one is in India, or it might have been China, and it equates to, I think at the time, I remember looking it up last year, it equates to around 1/20th the size of Greater London in terms of square miles. So if you think about it, the size of Greater London relative to the world is nothing, it's a speck. And if you were to cover that area with solar panels, then you could actually power the world's consumption in terms of electricity for a week. Of course, this is all theoretical, and it's not something that you should talk about in your exam questions. I'm just trying to give you a few interesting facts, I think. And a lot of these renewable sources of energy, actually, once they're built and once they are actually started, the running costs are quite low. And it says, finally, many technologies improving to produce more electricity and becoming less expensive. So actually, in the long run, what that means is all of these sources of energy, their starting costs will begin to reduce as more and more people take it up. The disadvantages for all of them, perhaps except hydro, is that they are unreliable, because whilst we can predict the weather, it can change. It can change, and it does change, and our weather predictions aren't 100% accurate. Initially expensive, so quite a large payback time over years, even decades. Tidal and hydro destroy habitats. So does wind, to be honest. In terms of, it's been observed that birds that once lived in a particular area, once wind farms have actually been installed there, then they no longer come into that area. And that's been seen actually in areas in Cumbria and in certain parts of Scotland. Wind and noise pollution and eyesores we already discussed. So at this point, I think what you should do is pause this video, gentlemen, and be able to just make a quick summary of advantages and disadvantages of each of the four sources of energy before we continue to the next part of the lesson. Okay, so what we're going to do now is just have a look at some questions that come up for this particular topic. Now, I've handpicked these questions. Now, all of them come from past paper questions in the last 4 years. So I think the oldest one is 2016. What I'd like you to do is I'd like you to have a read through the question, pause the video, attempt to answer the question, and then the next slide I'll be going over the answers. So go ahead and do that now, gents, and then we'll have a look at the answers together. Okay, so discuss the advantages and disadvantages of the plan to build thousands of offshore wind turbines around Britain and the suggested electricity power link between Britain and Iceland. Now, obviously, you were given loads of information here. Now, if you just ignored all of that and went straight to the question, this is obviously your first fault. So please make sure, as we always say, read every single word that's on there, read the information, and make sure your answer is relevant to the actual question itself. The way I would have split it up is I would give, as you can see there, talking about the advantages and disadvantages of the wind turbines. Now, I'm not going to go through these again because we discussed them, obviously, in the previous slides. But the points that I would like to talk about are just here: linking. Now, this will get you the higher level um, marks in the question. You see, because it says here, discuss the advantages and disadvantages. That's straightforward enough. And the suggested electricity power link between Britain and Iceland. So, really, it's asking you, I suppose, to think further and be able to um, apply your knowledge to the particular context itself. So the linking, I've said that income for Iceland, for example, there will be an impact on the income for Iceland using Iceland's available energy resources, because as it says in the text itself, we know that Iceland is a massive exporter of geothermal energy. Obviously, whilst we haven't discussed this, this is something that we'll be looking at in a bit more um, detail. But it does obviously talk about that. It says that in the first couple of sentences here, that Iceland is the only country in the world generating all of its electricity. Now, just think for 1 second. That's 100% of electricity being generated by geothermal and hydroelectric. In other words, people in Iceland don't have any electricity bills. And actually, a lot of the time, they have a surplus of generated power. So much of that can obviously be used, outsourced, and be sold to the UK. Hence, for Iceland, this means a great increase in income. Provide electricity when wind does not blow. When our wind farms are in their period of unreliability, then obviously we can draw on that extra power coming in from Iceland. Provide electricity at times of peak demand. Again, we can draw on that additional power source when our own renewable sources or even our traditional fossil fuel factories are not able to generate for the extra peaks. Excess electricity from Britain, i.e., windy days. Now, this can actually go back to them. So, for the UK, it could be a source of income. So, excess electricity from Britain to Iceland and used to pump water up to store energy. I mean, that's less of an advantage. It's probably quite a small thing, to be honest. But I put it in there because it's a legitimate point. So for you guys, when you come to answer this particular 6 mark question, I've broken it up into 3 sections because looking at the question itself, advantages is one, disadvantages is another, and then everything that comes after the and in bold is the linking part. The next question, gentlemen. Iceland is a country that generates nearly all of its electricity from renewable sources. In 2013, about 80% of Iceland's electricity was generated using hydroelectric power. Describe how electricity is generated in a hydroelectric power station. Include the useful energy transfers taking place. Please, when you answer this question, gentlemen, think back to the work that we did in Unit 1 when we were talking about energy transfers. So rather than saying kinetic energy turns into gravitational potential energy, which turns into this, no, we're saying that energy is one. Energy from X store is being transferred to whatever energy store it's being transferred to. And if you want to talk about pathways, then that's even better. So go ahead, pause the video, try this question now. Okay, so now that you've done that, hopefully you've all attempted it, this is quite a straightforward one. Water moves from higher level to a lower level. This is in terms of physically water going from a high place to a lower place because obviously on one side of the dam it's building up and it flows downwards. Transferring energy from the GPE store to the kinetic energy store. So the energy is being depleted from the gravitational potential energy store and it's going into the kinetic energy store. Rotating a turbine, as it does so with all of these renewable sources of energy, and that drives a generator. I've said driving or turning or spinning for rotating, not moving. If you simply put moving down, then this is not going to give a sufficient description of the idea that these turbines are spinning around a drive shaft, which is in turn powering a generator. So be careful about your wording there. And the final point to get the last fourth mark, transferring energy from kinetic energy store via the electrical energy pathway. Because of course, that's the end product. At the very end of all of these energy transfers, we are actually producing what we call electricity, which of course you and I know is current moving down a cable. Okay. Next question. This is a very typical question, another 6-mark question. You are given lots of information. Now, this question, you should really be focusing on payback. It's asking you to compare the advantages and disadvantages of the two methods. If you're given initial costs, then expect to be talking about the economic viability of each of the different options. If you're not really being told how much profit you're making a year, then I suppose you can't really talk about payback, but you can certainly talk about comparing the initial costs. As a rule, if you are given figures in a question, then those figures should actually, or a calculation using those figures, should feature in your answer. So pause the video now, gentlemen, read the question, have an attempt before we look at the solutions. Okay, so I've put down advantages of both. They're obviously both renewable sources of energy. They have no fuel costs. Both have very small running costs and no carbon dioxide is produced. Now, a running cost is different to the startup cost. Okay, so whilst they're both quite expensive, relatively expensive to start up, once they've actually been implemented, then actually the running costs are very cheap. Advantages of wind: higher average power output. Simply saying produces more energy is not detailed enough. Advantages of hydroelectric: constant, reliable power, because obviously you're aware of the amount of water that's building up, and lower installation costs. Do the simple calculations, meaning, say, by how much is it actually lower? Looking at the question there, I can see that it's cheaper by £30,000. Disadvantages of wind: higher installation costs. Again, I would specify by how much higher or more expensive it is. Variable, unreliable power output, of course, as we discussed, may kill birds, bats, or affect any other natural habitats in that area. Disadvantages of hydroelectric: lower power output, may kill fish or may damage habitats, more difficult to set up. Okay. So again, I've used all the information they've given me. I've used any knowledge that I have that I've learned through the content, and I've applied it to this particular question itself. Now, the very final question, gentlemen, you can't actually see, but that is a 5-mark question. Obviously, you can see that on your PDFs. So this question itself is a 6-mark question. It's a mathematical question, so they're not always necessarily 6-mark sort of mini essays. And this question, if certainly in the triple book, actually, if you look on the first page of P3.2, you'll see in the Go Further box, it actually refers to these sorts of calculations. It does also do that in the combined science. However, without knowing the equations, you obviously will not be able to do this. So it says the average mass of air passing through the blades of one wind turbine is 51,000 kilograms per second. Then it gives you the density of air. Write down the equation that links density, mass, and volume. You'll need to do that. And then from there, it says calculate the volume of air passing through the blades of one wind turbine in 1 second. Give the unit. And very important, to 2 significant figures. That's 5 marks. Pause the video, gents, and attempt these 2 questions, which totals up 6 marks. Okay, now that you've done that, let's have a look at the solution. Now, I've actually taken this directly from the mark scheme because it was a bit fiddly to actually do the calculations on PowerPoint. Here's the original question. Now, the very first equation is density equals mass over volume. Now, I'm just starting to think, have we actually covered density? I think we have. In If not, then I suppose you wouldn't have known that. Apologies. Now, just a quick point. This letter here is not a P. This is rho, which is a Greek letter. Rho, which obviously in this case denotes density. So density equals mass over volume. Now, if you look at the equation, it's fairly straightforward. Using the same equation, you take the density, which you're given here is 1.2 kilograms, equals, you are given the mass, which is 51,000 kilograms, divided by volume, which is of course what you're trying to work out. You rearrange the formula to make V the subject, and you solve it this way. Because of the significant figures, you can see that V equates to 43,000 and the units being meters cubed. Now you can see the marks awarded for showing the working out, and the method that you can see here, gentlemen, is exactly the way that we show you in class. This idea of quoting the equation, substituting in your figures, and giving the final answer. So please, please, please make sure, I know we say it all the time, but people always forget, make sure you write your equations in exactly the same layout that you see there on the mark scheme. And sometimes actually, even when people get the working out wrong or the final answer wrong, you'll find that they may have picked up 1 or 2 or even 3 marks in the working out beforehand. Okay. So, gentlemen, that's the end of that. Please make sure now that you submit a PDF copy of the questions to the Shobi folder in your teacher's Shobi class for Friday the 15th. Thank you very much. See you soon.